this one. Okay, so it's a counting operation and it's exact. Let me go back to the mole subway. Where is it? I can't see everybody in the chat either. Where is? And there we go. Okay, I see we have 16 people. Okay, so we're doing well. 17, excuse me. Okay, so at any rate, let me take what we did last time. We can go from grams of X to moles of X using the molar mass. And we can go from moles of X to molecules or atoms. Let's just say molecules for now, using Avogadro's number. And so this is the new thing. I can go from moles of X. Yeah, you know what? We did do this in the lab. I'm basically doing this all over again. Now I remember. It's okay though. I had this on the whiteboard. You guys remember this at all? I hope you guys remember this.
Yeah, I have pictures of it.
Okay. I thought that was a pretty good lecture, actually. It did. So anyways, we can go from moles of X to moles of something else in the chemical reaction using the mole ratio. And those are the coefficients in the balanced reaction.
Guys, like the
Question? Was there a question?
Disappeared.
Oh, I'm sorry. If you guys, it's okay to ask the question. If you want to ask the question, we can stop for a sec. I didn't hear it, but okay. Also, once we get to moles of Y, then we can also, there's a subway on the other side. I can go to grams of Y using the molar mass. I can go to molecules of Y using Avogadro's number, right? And so let's bring back that equation. NH3 plus 3H2 goes to 2NH3. If 10.5 grams of hydrogen, or maybe we should just do moles first. Excuse me. Let's do moles first. If 3.8 moles of hydrogen react completely, comma, how many moles of ammonia will form? Question mark. So for this, we have to, which stop are we on? Which stop are we at and where are we going? Where are we here? Where are we? If we have moles of hydrogen. So usually, also, like I like to start over here. This is what I call the known. And over here, this is usually what I'm trying to find. I'll call the unknown, right? Now, so which one, what is my known? My known is the 3.8 moles of hydrogen. So I'm here and I want to go there, right? So let's do that. So we have 3.8 moles of hydrogen. And then what is my mole ratio of hydrogen and ammonia? Anybody? What's the balanced chemical reaction say?
3 moles of hydrogen.
3 moles of hydrogen to 2 moles of ammonia. So where do I have to put the 3 and where do I have to put the 2?
3 at the bottom, 2 on the top.
Good. 3 moles of hydrogen on the bottom to cancel, 2 moles of ammonia on the top to find out about. Okay. How many sig figs is this one?
2.
Good. That's 2 sig figs. What about this one here?
1.
Well, actually, it's a counting
Right.
operation. I said it's exact, so it's actually infinity. So sorry, that's okay though. So then my answer should have 2 sig
2.
figs, right? Okay, so I'm gonna get in my calculator. Clear, and 3.8, whoops. 3.8 times 2 divided by 3. That's pretty straightforward, huh? And then, okay, so 2.53333, but to 2 sig figs would just be 2.5 moles of NH3. Okay, so this is the quintessential new idea that we're doing, right? This thing here, this whole, that whole thing is the only new thing. Now we don't have to start at moles and go to moles. We can start at grams, go grams to moles to grams. There's a lot of different pathways here. I could go grams to moles to molecules, or I could go molecules to moles to molecules, right? You know, there's many different ways. You have to read the problems really carefully.
Are there any shortcuts, or do you have to do like go through all those steps?
There's no shortcut for this one. And for that one, you have to have a balanced equation. I could, if you guys want, I could show you a shortcut for these. Do you want to see a shortcut for those? I think it can actually, someone asked, is this going to be on the exam? Well, I would guess it is. I think, to me, this is, I mean, I can't speak for the lecture instructor. The lecture instructor is going to set up the exam. But to me, this is like the most fundamental stuff of this class that you will want to learn. And this will, if you learn this well, this material here, then you will be in a very good position for understanding Chem 1A. So totally critical. Okay, so this is the core thing, but let's just continue. What I'll do is I'll keep the mole subway up there, and let's just, because I like it, and let's do a different problem. If 10.5 grams of hydrogen react completely, comma, how many grams of nitrogen reacted? Question mark. Okay. And this one to me is kind of a really common kind of problem where I'm given a mass of one thing and I want to find the mass of another. And so I could write out a set of steps for these if you guys would like. Would that be okay? I mean, but in a sense, you're just kind of putting it together. So for me, step 0 is have a balanced equation. If you don't have a balanced equation, then you're just guessing at the end of the day. And you might get lucky if it happens to be 1-to-1 or something. And then the second step is use, or I guess that if the 0, if that's the 0 step, the first step would be use the amount of the known, usually grams, comma, to find, to find grams of the known. And then once I've done that,
Unknown.
I'm sorry. Gosh, I totally ruined this. Sorry. Mr. Teacher, use amount of the known to find not grams, but moles. God darn it. I'm so sorry. Okay. Anyway, 2, use moles of the known, what you just found, to find moles of the unknown. And well, I'll go through this whole thing in a second. And then lastly, use moles of the unknown to find grams of the unknown. Or actually, let's make it more general. Let's say amount. It could be molecules, yeah? That's why I didn't put grams up here. I said amount, usually grams. Okay, so let's do this then. So if I have, so step 0 would be NH2 plus 3H2 goes to 2NH3, balanced equation. Step 1, so let me actually, I want to put these together, but step 1 would be, I had 10.5 grams of hydrogen. Let me put this more close, and then times 1 mole of hydrogen over 2.02 grams of hydrogen. Did you guys need to see me calculate the molar mass of H2, or is that okay?
Are you on step 0 or step 1?
I'm sorry, so step 0 is this, the balanced equation. So let's go back. So step 0 is balanced equation. Step 1, use amount of the known to find moles of the known. So here's, my known was the 10.5 grams of hydrogen. So this is my known. And I'm converting it to moles, yeah? Okay. Now I'm gonna add step 2 directly to it. Step 2 is, so if these grams cancel with grams here, I have moles of hydrogen. So now I'm going to use moles of hydrogen to find moles of moles of nitrogen. We want to, this is a different problem, huh? Because let's go back to the question. How, if 10.5 grams of hydrogen react completely, how many grams of nitrogen reacted? All right, so what's the mole ratio between hydrogen and nitrogen? Let me put a parenthesis. That's not a coefficient. Or circle it. Okay. So what's the mole ratio between hydrogen and nitrogen?
3 to 2.
Okay, I have a 3 here. What's in front of this?
1.
One
Sorry.
There's secretly a 1 in front of it. So it's
1 to
3
3.
to 1. Okay, where does the 3 go and where does the 1 go?
On the bottom, 3 goes on the bottom, 1 goes on the top.
3 moles of hydrogen on the bottom, 1 mole of nitrogen on the top. So now I'm going to cancel moles of hydrogen with moles of hydrogen. So if I did this divided by that, now I would have moles of nitrogen. That's step 2. I found the moles. I used the moles of the known to find the moles of the unknown. So then step 3 is use the moles of the unknown to find the amount of the unknown. And in this case, we wanted grams. So I'm going to want 1 mole of nitrogen on the bottom to cancel, and that's equal to 28.02 grams. And I could show that calculation if you guys would like to see that. But that's the process. Okay, so, oh, I guess we could calculate it. Okay, so calculator, on, clear, 10.5 grams of hydrogen divided by molar mass of hydrogen, 2.02, times 1 divided by 3. So divided by 3, and then times 28.02. So I can just do that in my calculator. Multiply, multiply, divide, as long as I don't have any exponents, right? If we had exponents, then like I was talking about before, I would use a parenthesis. And then what do we get? We get, it looks like 4.8549 times 10 to the 1. So, oh, how many sig figs? How many sig figs is this?
3,
3. How many sig figs is that?
3,
3. How many sig figs is that?
infinite,
Good. Counting operation. How many sig figs is that?
infinite for the 1, but 4 for the grams of nitrogen.
I would say for the molar mass is 4. Yeah, the 1 comes about by division, so it gets ignored. Okay, so my answer should have 3. Let me put the equal sign down here. So I want 3. So it 4.85 4.85 times 10 to the 1, or we could just turn that into a number, 48.5 grams of nitrogen reacted. Oops, is my pen going out? Okay, so there we are. And that's kind of the idea. So someone said 28.02 grams is the molar mass of N. No, so nitrogen on the periodic table is 14.01. But my formula is N2. And 1 mole of N2 has how many moles of nitrogen in it? It would have 2 moles of nitrogen. And so that's the Y for it's basically 2 times 14.01, right? Okay. Okay, it sounds like people are liking this. So that makes me happy. I can see the chat panel. All right, that's good. Yeah, so yes, so 1 mole of nitrogen, 1 mole of N2 has 2 moles of nitrogen atoms inside of it. Does that, because, you know, one, here, I guess I'm out of paper, I'll just flip it over. So 1 N2 has 2 nitrogen atoms, yeah? Does that make sense? Okay, I think it's clear then. And so I could do the same thing. I could multiply this by 100 N2s would have 200 nitrogen atoms. 1 mole of N2 would have 2 moles of nitrogen. Yeah. Okay. So be careful, I guess, is the cuidado. All right. Be careful, because that will happen constantly while you're doing these calculations. And be careful. I don't know. I could keep doing examples. Before we go further, do you guys have any questions?
I actually have one question.
Okay.
So I wanted, I don't exactly know, like, from, you know how you were talking about the stations, different stations, like in the little bus train or whatever it is?
Oh, the mole subway. Yes.
Yes. So what exactly are we doing for this problem? Like, where are we starting for this problem?
Okay, so you see my subway here? So we went from grams of hydrogen to moles of hydrogen to moles of nitrogen, and moles of nitrogen to grams of nitrogen. So you don't always have to go from reactant to product. I could go from reactant to other reactant, or technically I could go from product. I could say if I made you know, 40 grams of this, how many grams of that reacted? But whatever they give me the amount of, that's my known, right? When they gave me, where did it go? When they gave me 10.5 grams of hydrogen in that first question, that was my known. And then the nitrogen was my unknown, right? So that's really careful to, you know, that's the known. And the thing that, and when it says how many, question mark, that's my goal. Oops, got cord over here. There's a way to tether it or something. So this thing here is my unknown, right? That's what I want to find. That's the eventual goal. That's the points on the test, yeah? So it's really, you know, there's other skills involved. You want to read the question. I'm writing these very simply, but you want to read the question. Shoot, you guys want to, I could back up and we could talk about problem solving in general. There's some other questions I saw on the chat board for a sec too. Let me go to those. So, so this worksheet is due not tonight. When's it due?
Next week.
Yeah, next Thursday. And so I would like to get it before the lab. Okay. Yeah, so, and then someone else, yeah, so the page 52 to 55 worksheet was due today or tonight, yeah? So that one's really, don't forget to do that, right? That was the single displacement and double displacement, yeah?
Uh-huh.
Okay, this one is the quantities. All right. I guess we've answered the questions I see in the chat board. All right. Were there other questions? Did I answer his question about the mole subway? I hope I did.
Yeah.
Okay. So, I mean, I guess the main point is be careful. I mean, most commonly, you're going to go from grams of your known to moles of your known to moles of your unknown to grams of your unknown. But that's not the end of the story. You could also go down to molecules, right? Or you could find molecules. I mean, you really have to read the questions carefully. And that's kind of the end of the story, I guess. I don't know. So any other comments or questions? Does this sound like you have enough to be able to do this? So there were, okay. I guess the other thing was about the graphing calculator. I don't know which one you have. Let me pull one off the shelf. And I don't know if this one has a battery or not either. I have no idea. Oh, it does. Okay. So this is a graphing calculator. Would you guys like to look at graphing calculator really quickly? Anybody? Oh, someone had a question. Where is it? Oh, okay, good. So someone has this graphing calculator. So I'm gonna just really quickly. So they wanted to do exponents. Is that okay? So I'm trying to show it. So maybe I get the lamp glare away. Okay, so that capital E is time. So let's write that down. So capital E equals 10 to the whatever, 10 to the, lowercase e is actually what they call the natural exponent. And that's actually so that you also have those on here. Let's not bother with E, but that's an irrational number like pi. It's something like 2.718. It goes on forever. But for scientific notation, we're always going to use 10 to the. So there's actually a couple ways to do this. So I think there's, I don't know if you can see this very well, but there's an EE button here. It's the blue silk screen on the top. But I just use the 10 to the X. I think I can show this closer. There we go. Focus camera. Well, anyway, where my finger is, it's log if I just push it. But if I hit second and then log, then it's the blue. It's the 10 to the X.
Do we need to stay for this if we don't have one of these calculators?
Well, are there any other questions? Does anybody else have questions that I can answer? Or do you feel like we did enough practice that you guys can go do the worksheet?
Yes.
Okay, so I'm gonna just turn everyone loose. There was the other question of a pre-lab. I think I'm just gonna skip it and just let it ride, and I'll just grade it as a lab. Is that okay? Or I could make a quiz. What would you prefer?
Skip it, please.
I'm sorry?
Yeah, make it part of the lab.
Okay, so so just turn in the worksheet, and then that'll be the lab, and you'll just get a lab grade for that. Okay.
Okay.
We'll just keep it simple. Okay. It sounds like the person that was interested in the scientific calculator lost interest in it also. Is that correct? Oh, no, you still want help. Okay. So let me, okay then. So I guess I'm going to do the calculator really quick, but I'm going to let everyone else go. If you guys, unless you come up with some questions, I'll be here for a few more minutes. Oh, I have 10 minutes, looks like.
I have
Unless people wanted to stay later.
one quick question.
And also, while I'm at it, I'm going to stop recording too. So
which lab is it this time? Sorry.
I'm sorry. The question is what lab?
Yeah.
So the lab that's due tonight is...
Oh, the 52 and 55, yes. And then the next one is
can I go to...
Sure,
if I get out a video, I can show you. Let's do the calculator in a second. Hold on, I'll show people really quickly. Can you just hang on for a sec? So let me, how do I go to share screen? And, okay. Share.
It says single and double displacement reactions are due. Well, they were due at 6:15 at the beginning of class.
Yeah, and I mentioned that at the, while we were Zooming last week, and I thought I was clear, but, and people could email me if they had questions. But let's, so what's due next week is the worksheet. I think that was the question. So let me go really quick to, not that, but where is our, no, oh, darn it. Where is everybody? Over. There it is. Okay. So it's this thing. It said, let me go back and show where it came from. So if we go to modules, who's the person that had the question about the worksheet? Are you still there?
Mm-hmm.
Okay. So can you see the modules?
Mm-hmm.
Okay. So we go down to, where's my lab stuff? Where did it go? I'm sorry.
Sorry.
There it is. Lab section 106. Can you see that?
Mm-hmm.
Okay. So people had uploaded the KCL 03 KCL lab. I thought most people did that.
Mm-hmm.
I've had a lot less of the single and double displacement. So those you were supposed to fill out the worksheet and then click on this assignment and then upload it as a PDF. So I'm going to create one of those for this one. I haven't done that yet, but it will have, you see how it has like a pencil and paper icon?
Mhm.
So this one has a paperclip icon. That's a file. This one
Mhm.
has a paper and pencil. That's an assignment that you can upload as a PDF. So I'm
Mhm.
going to create a paper and pencil upload assignment for this one. But right now, this is the file. So you want to click on this,
Mhm.
and then you can download it as a PDF. I'm not going to download it, but I'll just show you. This is the
Mhm.
worksheet. And here's what we talked about. We talked about the mole subway,
Mhm.
right? And so there's some review. And then we talked about quantities in a chemical reaction. And basically the new thing, which I don't like how this worksheet does, is I would have talked about the mole ratio more, but that's okay. They do talk about it. How many molecules of CO2 and H2 would be produced when 2 molecules of ethanol are consumed? So basically the idea is you have to have a balanced equation, right?
Mhm.
And oh, the balanced equation. So there it is. Let's do a balanced equation. So there's this worksheet's kind of got everything. It's got balancing and moles, and then here you're just going from moles to moles. 3 moles of ethanol, and by the way, this thing here is ethanol, the C2H5OH. And you know, if you guys get stuck with a question like that, you know, there's this thing, I call it they invented it in the 90s. They call it the internet. You can just, here, if you look at my screen, I'm not trying to be pedantic exactly, but just that you can find anything. Like I
Yeah.
can, here, ethanol, bam, and, oh, there it is, C2H6O. Or C2H5OH,
That's
pow.
what internet.
So it's you know, but anyway, so sometimes it's what they call an organic chemical. You can look them up if you need to. But anyway, so here you're just going from moles to moles. How many moles of oxygen react when 0.25 moles of carbon dioxide are produced? Moles to moles. Then let's see. Still going moles to moles here. Okay, so when we get down here, then we're finally going grams to moles to moles to grams, right? This is so when we get to part 3, that's actually the very last stuff that I did. Here's drawing a molecule picture. Oh, gosh, I didn't talk about excess reactant. Let's see. So, uh-oh. I think I lost everybody too. How many people are left now?
I think we only lost like 1 or 2 people.
Okay, so let me check back in for a sec. Let's see if I can I spotlight video. How do I go back to video? Where do I see the chat window? There we go. There's some things I don't like about. Okay, so where were we? I guess I should go back to, okay. Can you guys see my video feed now and you can't see the screen? Is that correct?
But I can see both.
You can see both?
Yeah.
Ah. God. Can I expand it? I want to make this bigger. It's just not that great. And then, so you guys can see both also now? Oh, because I'm on desktop. How do I go to video? Come on. Video settings. How do I go back to video? Oh, let me go to whiteboard. So is that okay if I'll go to whiteboard? I can type pretty fast. Are you guys on board for this? I'm gonna go to whiteboard.
Mhm.
Can you see the whiteboard now?
Mhm.
Okay, let me put the chat there, and okay. So, oh, I have less than a minute also, so this kind of creates a problem. So what I'm going to do is I'm going to set up the whiteboard, but actually, we should go to I guess I got rid. Well, I could talk about. Let me talk about the limiting reactant. Hang on just a second. I'd actually want to go to screen. So actually, let me log people out. I'm gonna, because the meeting's gonna end in a minute, so we'll just start again. There's one other thing we need to talk about. Just hang on just a sec. I didn't notice that last part of the worksheet. I missed that. So I'm gonna get out. Okay.